When dealing with numbers in science, it's important to know how precisely we know a number. One of the main ways to do that is through significant digits, significant figures. So on this video, we'll be going over the 8 rules for significant figures and some examples to let you see it. I'm Ben, this is Physics or Bust. The first rule is that all non-zero numbers count. So if you have the number 123,456.789, all 9 of those digits are significant. So we would have a total of 9 sig figs with that example. Rule number 2 is that all zeros in between non-zero numbers count as significant figures. So if you have 200.1024, right? 200.1024, all 7 of those would count as significant figures. All zeros that are between non-zero numbers, 1 through 9, count as significant figures. The big issue is when you come to the zeros before and the zeros after. That's where most people mess up. So let's go through those rules. When we look at all these zeros here, there's a couple terms that we need to know. These zeros are all called leading zeros. These zeros are all called trailing zeros. Okay, the leading zeros are never counted as significant figures. So if you have zeros out this way and there's no non-zero number out here, then those are not counted towards your significant figures. So going from left to right, your first sig fig is going to be the first non-zero number you encounter. And then from there, you continue to count your zeros all the way to the end. When it comes to the trailing zeros, these trailing zeros count depending on where the decimal point is. So if we have the number 10,000, just written like that, since there's no decimal point there, this only has 1 sig fig. We only count the 1 here as a significant figure because there's no decimal point. But if we were to say 10,000 and put a decimal point there, then all 4 of these zeros do count. So this would end up being 5 sig figs. Right? If we continue to put zeros, so we say we have 10,000, but we say 0.000, then these 5 and those 3 are all counted towards the sig figs. So we have 8 sig figs. So the difference is where that decimal point is. Right? So these 4 rules here, we have the leading zeros do not count, so that those are the zeros to the left. Trailing zeros in a number without a decimal do not count. With a decimal do count. And if they're to the right of the decimal, they do count. Right? So as long as there's a decimal point, you're going to be counting those trailing zeros. And then the last two rules are much simpler. The zeros are the hardest part. So the last two rules are much more simple, that when you have an exact number, say there's 22 people, that can count as an infinite number of significant figures. Because really there's 22.00000 on and on number of people. You're not going to have a partial number of people. So when it's an exact number, you can count it as having infinite significant figures. And when we look at something written in scientific notation, for instance, 5.98 times 10 to the 23, all the digits on this part, on this side of the times 10 to the 23, count as significant figures. So we have 3 significant figures in that example. Now, if we were to include some zeros in here, 5.9800 times 10 to the 23, that would make it 5 sig figs. And you don't see this often, but if someone for some reason included some zeros over there, those are leading zeros, so those wouldn't count. But you could just ignore those, which is why you pretty much never see those written, except for when it's something where they're writing it like this. Right? These 3 zeros then wouldn't count because they're leading zeros on it. But once again, doing a slight change here, right? These 2 trailing zeros would count because there's a decimal in the number and they're to the right of a non-zero number. So the last 2 rules written out here, we have the exact numbers have infinite number of significant figures. And number 8, all digits in a number written in scientific notation do count towards significant figures. So just as a comprehension check, you guys tell me how many significant figures each of these numbers have in the comments below. Remember to like and subscribe, and I'll catch you on the next video.